How are we doing, my Jerry Seinfelds, my integrated math students, my awesome students that I'm a big fan of, and I appreciate you for checking out this video on the 1.7 Formative. If you're watching this, you're most likely watching it because you're going to be retaking a quiz that's similar to this, and we'll just have some different numbers switched around. So I wanted to chat about them. Thank you for caring about your grade and your progress in this course, and I hope you get something out of this. This first problem has you talking about the share price of an Apple computer stock increasing by 15% every year. So I'll highlight some takeaways, some things that I think are really important. Apple computer, not super important to the context, but that's the kind of computer you have. So, okay. I see that the stock is increasing. So ideally, we want our money to go up, above, and beyond. If it doesn't, that means that we did something wrong. So that's a good thing to think of, is that we want our stock to increase. And in this case, it is increasing by 15% per year. What's the common ratio that is appropriate for the geometric sequence representing the price of the stock? I know that I chatted with sets 3 and 4 pretty heavily about this in the Kahoot, saying that we want to take the 100% of the amount of money that we put in, and I use dollar bags to talk about this. So we want the 100% that we put in. So think of this as our investment. And if the stock's going to give us an additional 15%, that's considered a fraction of our money bag. So think of this as, I don't know, a small corner of the money bag. And that's how much the stock is. And so since this is increasing, we add these two together. If it was decreasing, we would subtract. But in this case, 100 plus that 1 or 15% would give us 115%. But remember, we want a common ratio, or in this case, a decimal. So if we were going to the decimal, we would scratch out this percentage sign, similar to what Bobby said in set 3, 4. We would then take our decimal point, move it over once and then twice, drop it like it's hot. So our common ratio here should be 1.15. And if you want to write that, it's positive, sure. But all you would need here is the 1 in the front, and then that's it. To the next one. I know that this problem you didn't have to complete, but I'm going to talk about it because as you move into this retake, you're definitely going to have to do this. So I have the dump truck decreasing by 6% every year, appropriate common ratio to use. Since this is decreasing, I know that I'm no longer going to be getting 100% and then some. So I'm deducting 6%, which if we take this subtraction, 100 minus 6 leaves us with 94%. Similar to the previous problem, going from percent to decimal, get rid of the percentage sign, move that 2 over, drop the decimal point like it's hot. So 0.94 is our common ratio here. This is similar to in 1.7 with Augustus and his candy pile. After he accumulates the 100,000 candies, he starts to give them away. And I think we had a little bit of a discussion about how it would be stronger to multiply with 0.4 versus deduct 0.6 of the pile. So I hope that one helps. Let's keep this momentum going. We have these 2 points here. F of 2 is 6, F of 3 is 12. Luckily, this wasn't mentioning if it's arithmetic or geometric. So if you wanted to take this to a table, it would look something like this. You're always encouraged to use the other representations of our expressions. So when n is 2, the outcome was 6. If n was 3, the outcome was 12. You have two options with how you could take this further. You could notice that if it was arithmetic, it would be adding 6. Whereas if it was geometric, hopefully you say that it would be multiplying by 2. And so you have a few options with how you could go further. For this, I'm just going to focus on the arithmetic. So 6 plus 6 gets you 12. 12 plus 6 gets you 18. Next term would be 4, which is what we want. So that's 18. If we took this further, just adding 6, 18 and 6 gets you 24. So this is 24. Boom. If you wanted the geometric, you could just take the previous, multiply by 2. So this is for the arithmetic. If you wanted the geometric, you would say that f of 4 is 2 versions of 12, which is 28. Or if you were going for f of 5, 24 times 2, which is 48. So notice that arithmetic and geometric would give us different outcomes. But since I'm not stating which one it is, I'll leave it up to you to just find out which one you want. Hope that helps. Let's keep this moving. Moving on, running on empty, moving on. This one's very similar to 1.2 when you're just plugging in values, and it's honestly simple. You are given this function. You have this f of 4. So anywhere, well, you know what? I'm actually going to go above and beyond. I'm going to highlight where n is. So I see n here and here. And now this is saying instead of n, I want to use 4. So think of it as if you're just going back. You're putting in 4 here and also here. So if you do that, you would get 3, now 4 minus 1, and this is helping you find f of 4. That being said, you want to take this further because 4 minus 1, you can rewrite that to 3. 3 cubed, can you take that further? Sure can, 27. So 27 is your answer here. Leaving this doesn't do a ton for me. Leaving 3 cubed, that's kind of lazy. Come on, take it further. You can do it. Ooh, my favorite, recursive and explicit. Recursive, I'm going to list out our steps here. I'm actually just going to list them right here. So recursive, I need to state 2 things. First thing is my starting point, which in this case would be the f of 1 equals 11, because f of 1 is talking about this first term, and then 11 is that outcome. So the first thing is the starting point. Second thing I want to mention is how the pattern's going. So I think in words, that's a good place to start. So let me just think. All right, it's jumping from 11 to 14, then to 17, and then to 20. Well, 11 to 14, that would be adding 3. Let's test this. 14 plus 3 does get you 17. So far, so good. And that works and will work just like that. So in words, I would articulate that this is the previous plus 3, and that equals the current. And I always think about this. I always think in words. What is this going to look like? That helps me articulate the function notation that I want to use. So whenever we talk about the previous, remember, we refer to that as f of n minus 1. And then pretty much just going term for term. So plus, would just be adding 3 equal sign current, we refer to that as f of n. So collectively, this was getting the function notation. So the 2 things that you would want to state as your final answer are here. You're stating that f of 1 was 11, and that f of n was equal to f of n minus 1 plus 3. Does that help? For the explicit, I think I've given steps on this before, but I need to find the zero term. I need to get the common difference. And then I want to frame my equation using those two things. So my zero term, I don't have that, but could I backtrack and get it? Because this is my first term, and this would be my zero term. So if I deduct 3, that would give me 8. So this is starting with 8. Common difference, as mentioned up here, was 3. So I'm adding 3. And this depends on my variable n. So I'll call that my explicit. So this, again, was my recursive because I had the previous term. This is my explicit because I can plug in any number for n, and it'll give me an outcome. 7, 7, 2, 6, 18, 54. I know that this is probably not adding 4 every time. This is probably multiplying 3 every time, but let me even double check it. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 definitely gets you 54. So I know that this is definitely a geometric because real G's multiply to get to the next value. If I was going recursive, similar to the previous problem, I need my starting term, which was 2. So I can say that f1 is 2. For the function notation, I know I'm taking the previous, multiplying that with 3, and that equals f of n. So those two things are what I would need there. For the recursive, or sorry, for explicit, I need that starting term, but I'm actually going to solve this one with a table. I think the table is helpful for the geometric situations. So I have n, I have f of n. I know that my first term is 2, second term is 6, which again was 2 times 3. I know that the third term was 12, which was 2 times 3 times 3, which is 2 times 3 being squared. I know that this was equal to 2 to the 0 power, or sorry, 2 times 3 to the 0 power. Do you start to see a pattern here? I hope you do, because it's starting with 2, and then it's multiplying with 3, and it's doing that n minus 1 times. Another option you could have gone with if you wanted to go back to the 0 term, and this is kind of an extra thing, but if you wanted to go back to the 0 term, you could say that this was going to be 2 times 3 to the negative 1 power, which in this case is just 2/3. So another answer you could have gotten is 2/3 times 3 times n. And it's actually safe. This is another equation you could have gotten. So this was using the 0 term. This was using the very first term. Both are correct. I would accept both of these. In particular, I really like this one because I try to avoid, I don't avoid it. I run into it because I'm not afraid of fear or math. I try to keep my exponent in his end. I hope that this video was helpful. If you have any questions, let me know. Thanks for watching.